In this lecture, we're going to look a little more in depth about how various things happen with regards to objects and primitives in Java. First, we're going to have a brief recap of some of the terminology and some of the usage of classes and objects in Java. And then we'll look at primitive variables and how they're actually represented in your computer's memory. And then we'll also look at reference variables in the same light. And we'll also look at ways you can get yourself into trouble using instance variables if you're not careful. So recall from last time that a class is a object blueprint. So you create the class file in Java, and then whenever you use this new operator, the JVM, the Java Virtual Machine, creates a instance of that class. So it takes that blueprint and it creates an object, and those are the different instances of the class. There is only one class blueprint. So for example, last time we developed a class that could represent a two-dimensional ball, and there's only one blueprint, but you can create as many instances, as many objects of that class as you want. What do objects know? Well, in the case of our ball object, they know things like where their position is and what their color is and so on. So here are the three different ball objects saying various things about themselves. And terminology wise, what an object knows about itself, its persistent state is its instance variables. And these are those things we declare as just like normal variables, but they're declared inside the class declaration but outside of any of the methods of the class blueprint. And here's an example. In the ball class, we had persistent state for the X position, the Y position, the radius, and then the color of it. And instance variables may be of a primitive type, as is the case with our location and our radius, or they may also be another object type, which is the case of the color of the ball. But importantly, this is persistent state of the object. So when you modify, say, the position or the radius or the color inside of any of the instance methods, then that change persists. So you can change things around about that ball object. So for example, I could take this blue ball and I could call my set color method, and it would take this color instance variable and change it to, say, red. And that change would, from that point on, that ball object would be a red ball instead of a blue ball. What can objects do? Well, these objects all can draw themselves. So we had a draw method. They can print out data to the console, so that was the toString method. They can change their color using the set color method, and they can move around. So I'll show you, I've added a little move method to the ball class, and they can also detect if they're overlapping with somebody else. So what an object can do is the instance methods of the object. So these are just like the static methods we saw previous to our foray into objects, but they don't have that static keyword. So any method declared in the ball class is an instance method, and it has access to all that persistent state stored in the instance variables. And here is just the signature of the various instance methods that we've implemented in the ball class. As I said, I added a bonus method, the move method, and so the move method changes that position X and position Y by some delta X and delta Y. So this allows somebody to nudge the ball around, move it up or down, or wherever you want to move it to. How do we get one of these objects to begin with? So we've got the class file, which is the blueprint, but you're going to have another program that's going to actually use the ball class. So you have some client program, and that client program is going to need to create three different objects of type ball, say, for sake of example. And The object stork is the constructor. So it's a special method, and recall from last time, it's a special method because there is no return type. You can't declare a return type. It's always public, and it's always named the same as the class. So it's named capital B ball, and it has to be named that in order for it to be a constructor. That's what makes it a constructor. And then then it's up to you to set the number and type of parameters to do whatever you need to do. So the whole job, whenever you think about, well, what should a constructor do? A constructor's job is to initialize that object and get it ready for use. And so you'll have the constructor, and you'll have it take whatever parameters you need to get that object up and running. And exactly what you need to do kind of depends on exactly what your custom data type is designed for. So I made a little object soap opera, and here is the beginning of the program. It's a client program that uses the ball custom data type. It creates a ball, and its name is Bluey. All right. When you first declare it, and you can just declare a variable, this says, please Java make me a local variable named Bluey, and it's of type ball. But at this point, we haven't actually created that object. And so Bluey is just this null, and so null is kind of like Bluey raging against the universe and wishing he had a purpose, but he has no purpose. When a reference variable like Bluey hasn't been newed, so if you haven't used the new operator and assigned Bluey equal to something and ran that constructor, it's equal to null, and it's a sad empty vessel, and it can't do much. But somebody comes along and creates Bluey, and so Bluey is very happy because now he has a purpose. He's a ball object, a real live ball object, and he's living at 0.1 x, 0.5 y, and has a radius of 0.1. Bluey's a bit upset though because Bluey is invisible. Nobody can see him, and so somebody calls his method draw, and now Bluey draws himself. Alright, but Bluey is not very happy. His name's Bluey, right? So he wants to be blue, but he's this, I mean, he's a nice, shade of mauve, but he doesn't really like that color so much. Before he draws himself, we can add a set color method, and so now when he draws himself, his color, so that state variable, that color instance variable, by calling this set color method, we've change that color instance variable to be blue. So then when we call the draw method, the set pen color is going to set the color to blue, and then Bluey draws himself in a nice manly shade of blue. Oh, well, who's this? Another ball object. Remember, we have one object, we have one class file, one blueprint, but we can create multiple objects from that blueprint. And Mauvey comes along and creates herself up at the top at the same X location, but at a higher Y location and a little bit bigger radius. And Mauvey likes very much that she's the mauve color. Now what's going to happen? Well, Mauvey is going to see if she overlaps Bluey. While she has not overlapped Bluey, she's going to move herself slightly down and then draw herself. So let's run that. I can pull that up. Let me pull that up in Eclipse. And here's the object. So there's Bluey, there's Mauvey. Oh, Mauvey's moving down, detecting for overlap. Oh, Bluey. So that's the last part I didn't show you, right? Once overlap is detected, Bluey sets his color to red and then draws himself, and then he blushes. So there's Bluey, there's Mauvey. Mauvey's moving down, and Bluey. Okay, so important points is we've got two objects of the same blueprint, and they both have their own unique state, and they can change their state. So Mauvey is mutating its state. It's changing it by calling the move method, and its instance variables are actually changing. Every time I call this, Mauvey's instance variable for the Y position gets smaller and smaller until eventually she hits Bluey. Whenever we have a variable, you must first declare it, and so every variable has a type. We've got the primitive types like we've talked about before, like int and double. Object types refer to something more sophisticated, so something that encapsulates perhaps multiple instance variables and has various methods we can call on it. All right, that's an object reference type. So when I say an object type or a reference type, I mean something more sophisticated. The primitive types are just that. They're primitive. They just hold a value. They don't have any methods you can call on them. They don't contain multiple pieces of data, whereas objects can contain multiple pieces of data. And so all these are examples of different custom data types. And notice the difference in naming convention. All right, type names of primitive types are always starting in lowercase, whereas object reference types always start in uppercase. So that's why really the string thing, in the beginning part, we kind of treat it like it's primitive, but it's not really a primitive. A string is a class, and it has multiple pieces of information. It has all the characters in the string, and it also has a bunch of methods you can call on the string object. Primitive types are really just a block of memory in your computer that holds their value, and depending on what primitive type determines how many of these little bits of memory. So computers store things, as I'm sure you're probably aware, they store things in binary, in zeros and ones, ons and offs in their circuitry. And here are some integer types, and they all have different sizes. Like a byte is the smallest one, and it only has 8 bits. And so it can only store very small integers, where short is slightly longer. Int, the one we normally use, is 32 bits, whereas the long, if you need to store really big integers, you store a long, and that holds 64 bits. Primitive types are just that. They're just a variable that's of primitive type just refers to some block of memory that can hold its value representation. And here's a diagram showing that. I set up a variable called x, and all Java know, basically that x in Java is just saying where is my 8 bits in the memory. So I've got my big, whatever, 32 gigabytes of memory on my desktop computer, and x is going to point to 8 of those bits. 1 byte of that memory is that x, and exactly what pattern of ons and offs are in there influences the value. So if that x is 7, then this would be the bit pattern in the memory. If I were to modify it, so I would increment x by 1, notice the bit pattern has changed. So the bit pattern now has incremented, and this bit pattern represents the number 8. That's a byte. We could have a bigger data type, the short. So the short has 16 bits of memory, and just like the byte, when it's assigned 7, then it's just got a lot of extra zeros in the front, and then the 3 ones in the end, and that's the binary code for the number 7. This kind of explains, we've talked about data types and what you can put where. This is why things like x equals y isn't going to work. X is of type byte and y is of type short, and you just can't fit. You got 16 bits of information here, you're trying to fit it in 8 bits of memory. It's not going to fit. And Java knows it's not going to fit, and it's not going to compile. You can't put a big cup into a small one. This is the big cup, needs 16 bits. You can't put it here. Vice versa, well, that's okay. That was primitive variables. Let's talk about reference variables. When we first declare ball b, so b is the variable name for something that's of this custom data type ball. If we don't use the new operator, what we have is b equal to this special null variable. And the exact specifics, I'm not going to highlight exactly how many bits or what those bits are, because that's dependent on the Java virtual machine and the architecture and the operating system, or who knows what, the phase of the moon. We don't really care, but it does refer to, there's some section of this memory that are the bits associated with that ball. And when we first declare it, that B is an unprogrammed remote control. We have the capacity, we have enough bits in our little cloud here to program that remote control, but initially it's set to null and it's an unprogrammed remote control. Once we do the new operator, then we're actually creating, now this blue cloud is going to tell us where to go to get all the information about the ball, like its X location, its Y location, its radius. Anything the ball knows about itself will be stored in another block, and that's why it's kind of a reference. The B variable refers to the blue cloud, and the blue cloud references where the actual object lives. And exactly how big this mauve cloud is determined by how much persistent state that ball object has. Here's me creating another object. This is the color object, so a built-in color class in the Java toolkit. And C is just a reference variable. It refers to some bits of memory, and those bits of memory get us to a color object. And this color object, in these bits of memory, it's actually going to store whatever color needs to know about itself. For example, it's red, green, and blue components. And just like primitive variables, it's no fair mixing and matching. You can't put a color object into a ball object. All right, and that's just the basic rule in Java. You can't normally do such things. You can, however, if you have two reference variables of the same type. So here I have ball B and ball B2. They both point to independent mauve balls, all at 0, 0, and one's, you know, slightly bigger than the other guy. And down below we see the diagram version of that. B is referring to some bits of memory, and those bits of memory gets us to the chunk of memory that stores the state of the first ball, and then this is the chunk of memory that stores that second ball. What happens if we do something like B equals B2? Well, we can do this. In the last slide I showed you can't assign a color into a ball or a ball into a color. But if I do something like B equals B2, what's actually happened, since these are reference variables, what we've done is reprogram this remote control. The B remote control was pointing to this first ball with radius 0.5. But when I do B gets B2, what I've done is reprogram that B remote control to control the radius 0.7 ball. And diagrammatically, what we have here is B has some memory that can refer to a ball object, and now B is going to point to or reference the same ball object. And B2 is still pointing to that same thing. So what we have here is two variables that control the same object. If I were to call B.setColor to red, this ball with radius 0.7 would turn itself red. Same thing would happen if I call B2. There's no difference really in what you would see in your program. B and B2 are what are called aliases of one another. There are different names that control the same underlying object. You know, not something normally you know, you would necessarily do, but if you do something like that, that's what you're going to get, and it's important you understand what's going on with references in Java. You're not creating, you might think, oh, I'm creating a whole new ball object that's, you know, the same as this guy, but you're not creating a new copy of this guy. All you're doing is reprogramming that remote control, and now you have two remote controls that control the same object. And we've essentially lost the ability, this mauve ball at 0.5, it's been kind of lost to the ages. We've you know, at first we could control it, but once we do B equals B2, we've lost control of that, and it's going to be garbage collected out. It's going to be deleted by the Java runtime system. And there's the Java virtual machine. There's the janitor, the garbage collector. It's gone. We call that an orphan. B has been orphaned, or the original mauve. This object here, the mauve, r equals 0.5 ball has been orphaned because no one refers to it anymore. All right, and this is a feature of Java, is you don't have to take care of this. The Java virtual machine will track if you've got an object and it's no longer available to anybody, it will go ahead and free that memory, which is important, right? Because otherwise this is taking up a chunk of your 32 gigabytes or whatever you have, and eventually if you had enough of these chunks, you'd run out of memory. And so the JVM comes along and cleans things up and frees that memory so you can run more applications and so on. Here's something else we could do. So I've done the same thing initially, so I've gotten B and B2 as aliases of one another. Then what I've done is B2, I've created a new ball. So this is a new mob ball, not to be confused with the old original mob ball. This mob ball is at 1.0, 1.0 and is of the same radius. Whenever you do the new, you're actually getting a brand new ball object that's taking up a new chunk of memory, and B2 no longer controls the red ball, B does, because B equals B2 reprogrammed the B reference variable to control that ball, and now B2 equals new ball reprograms this guy as well as the new side, so the right hand side of this creates that memory, and then you can control the mauve ball with B2 and the red ball with B. Let's look at some trouble you can get into with alias bugs. Instance variables all have a name, just like any other variable in Java, and so here are our instance variables of the ball class: position X, position Y, and radius. Local variables can also have names, and parameters, the parameters to a method are essentially local variables as well, and they also have names. Java will let you use the same name for instance variables, parameters, and local variables. Alright, here is an example, and I think this is, was this the code I had in my ball blueprint. There's no trouble here because my instance variables and my parameters to this constructor all have different names. Java won't get confused, and you won't get confused. What this is doing is taking the parameters to that constructor and copying the three values into the instance variables. So this is this works fine, and there's no problem with this. Here's a different version of the same thing. So can you spot what I changed? What is broken in this version? Alright, so you can see what I changed, right? All I did was I put that keyword double before position X, position Y, and radius. What I've done is tell Java I want a local variable. By putting that primitive data type in front of position X, I'm telling Java, nah, I don't want to really use the position X instance variable. Please make me a new local variable called position X, and I'm going to use that, which it will do, and copy the parameters X, Y, and R into those local variables. But then this constructor just scopes out, and those local variables are lost to the ages. This will compile and run. It just will not do what you think it does. You, in probably almost 99% of the time, intended these values to be copied and stored in those instance variables. That's the main job of a constructor, remember, is to set up the state of the object. And just by putting this double, you've kind of really broken things. So be careful of that. And Eclipse is trying to help you here. Notice those things are in blue, so recall Eclipse is always going to show you instance variables in blue. And when you do it this way, notice they've turned black, which indicates it's a local variable. And so you know right away, just by looking at the color, that you're in for trouble. How do we fix that? Well, okay, wait. Oh, so we haven't looked at fixing it yet. We're still breaking it. Here's another way to break it. This doesn't have the same problem I saw before. So before I had declared the type of position X. You might think this works, but you'd be wrong. This also has the same bug, and the parameters of the methods position x, position y, and radius are the same name as the instance variables. And the basic rule in Java is going to use the parameter variable or the local variable before the instance variable. And so because of that rule, this is actually not doing anything. This is saying, please copy into the local variable position x the value passed in as the local variable position x. It doesn't do anything useful. All right, and it certainly doesn't set these three instance variables. This will compile and run. It just does not do what you think it does, and you can tell because this is not blue. What you're expecting here is the instance variables on the left side to be colored blue in Eclipse, and they're not. Here's how you fix it, and it's not very complicated. There's another keyword though. You need to know the this keyword, and the this keyword refers to an instance of the object that's running the method. Whenever you use this, it's shorthand for yourself. And the reason it's useful is it helps Java disambiguate. So by putting this dot position x, Java knows, hey, I really want the instance variable position x, and don't do any of that shenanigans, using, copying a variable into myself. That's just silly. All right. And this is a very common thing you'll see is often you'll have a constructor and the parameters of the constructor will be the state of the object, and you've already chosen nice good variable names for these instance variables, and you don't really want to invent three new words for the same thing. So often, commonly, at least when I do it, is I just call these things the same thing, but then you must remember to put this dot. Otherwise, you'll get this alias bug problem. All right, so every class can have a main method. Why would we have a main method in our object blueprint? So ball is, the ball.java class exists to create our custom data type. So it declares the instance variables we need and the instance methods. So what the object knows about itself and what the object can do. Why would I need a main method? Well, the main reason you need a main method is for testing purposes. So as I develop my custom data type ball, I suspect I've done something wrong, or I just want to make sure everything's working right. I can create whatever. This is just doing, I'm creating a ball object here and one here, and I'm printing it out, and I'm seeing if they overlap, and I'm moving them around, and I'm drawing them, and so on. I can put whatever I want in there. And people who are using my class, so clients of my ball custom data type, don't need to use this main method. But remember, if you do Java ball, it's going to run the main method. So whatever you put on the command line after the Java command is the class it's going to run the main. Right? If I run Java ball, it's going to run the test main in my ball class, whereas if I run Java ball client, it's going to run the main method in the ball client class. So it's a good place to do testing and debugging, and certainly when you do your assignments, as you're developing your own object data types, you're always free to put in, main test code for some of the data types you're developing. It's always a good idea to develop a class and then test it rather than try and build the whole shebang in one go. That brings us near the end, so here's a little quiz to see if you've been paying attention. So you might want to pause the video here and see if you can put in a definition for these 5 important terms associated with object-oriented programming and classes and objects. Alright, so here are the answers. So remember, the class is the object blueprint. It defines the various things a custom data type can do, whereas an object is an instance of a class. So we have one object blueprint, but we have many objects, many instances of that blueprint. Instance variables represent what an object knows, or their persistent state. Instance methods are things a particular object can do, say move itself around or draw itself. And then I like to think of the constructor as the object store. All right, in order for a sort of class, an object blueprint to fulfill its destiny, you must create instances of the object, and you can't create an instance of the object without going through a constructor. All right, so normally you're going to declare constructors, though if you don't declare any constructor, you'll get a default one that basically just doesn't do anything. So we saw how primitive and reference variables are sort of represented at a low level. So it's good to understand a little bit about how the computer is representing things and understand some of the semantics of how reference variables work. So you understand a little better what happens if you copy a reference variable into another reference variable and so on. And then we looked at the trouble you can get into with alias bugs. So this is a very common problem for beginning programmers. So be very careful when you're creating your constructors, your other methods, that if you intend to use an instance variable, make sure you're actually using the instance variable and you're not using a local variable or a parameter to the method. And then finally, we looked at every class you develop in Java can have its own main method, and the reason you might have many main methods is a lot of the supporting classes, the object blueprints you've created to help your client do its job, you may want to test them independently as you're developing them.